How many questions did I give you on that worksheet?
3.
3, there is the 3. Okay. A 100 millifarad capacitor was allowed to fully charge up and then discharge to a resistor of fixed resistance, or a voltmeter measures the voltage every 100 milliseconds. The results are shown below. So we start off with 500 microvolts, and then every 100 milliseconds we measure the decrease in voltage. Graph this in an appropriate manner. Okay. Delete this old graph. Okay. So first we have voltage, and the unit is microvolts, mu volts. Starting at 500 and decreasing. 421. What's next? 354. 298. 250. 210. 178. 149.
125.
And 105. And then the time is just going up in 100s, isn't it?
Yeah. Millisecond.
Okay, so this is the time in milliseconds. Okay. Now, we don't graph this, obviously. If you remember the lesson, what do? Yeah, we can keep the time, that's fine, but what we should instead use is log the voltage. So if I just have the log of this, and instead I should then graph the time in milliseconds against the log voltage in microvolts. Is that part 1? Yeah. Okay, so insert chart. Scatter, very good, you're learning. Okay, what graph will we call this? This is log voltage against time. The x-axis is time in milliseconds, the y-axis is voltage in mu volts. I hope I have this the right way around. Is it backwards? Don't say it's backwards, don't say it's backwards. Oh, thank goodness. Okay, right. Let me just shrink this down a bit. Now, what's nice is it is the straight line. Okay. I'll put this down the bottom here. Now, that is part A, the graph. Part B, what's the unit of the slope? Now, I went through this in class, part B. Do you remember what the unit of the slope is? Well, firstly, do you remember what the slope is? Does anyone remember what the slope is? 1 over the time constant. And what's the unit for the time constant? In this milliseconds in this question, yeah. So the unit for the slope will be 1 over milliseconds, right? Well, what is 1 over milli? Kilo. So it's kilo per second. Or if you want, you can actually say that's kilo hertz. We've done hertz, haven't we?
No.
Yes. No, but we did it in the circular motion, didn't we? Yeah, frequency. I don't need to say kilohertz. Anyways. From your graph, estimate the value of the time constant. Okay, well I don't need to estimate because I'm a lazy son of a something. And I can read it from this. The slope is minus 0.0017. That's really small, but it's actually 1 over this. So, did I want the slope or did I want the time? I wanted the time constant. So the time constant, if you can hit this in, will be 1 over 0.0017. 0.0017. What's that, please? 576. So 577 milliseconds. Now, roughly. In the exam, they will allow for some error for reading the graph. D. How long for the capacitor to discharge?
5 times T.
Not for that, just 5 time constants. How much is 5 time constants? 2088, is it?
Yeah.
2885 milliseconds. Okay. Focus, Lee. What was the value of the resistor through which it was discharging? Now that's what you were saying, Andrew. So now we have to use the formula time constant equals RC. So R is time constant over C. The time constant is 0.577 and the C is 0.100. So is that 5.77 ohms? When will the voltage be 80 microvolts? Well, we can use our formula here. V equals V0 E minus T over tau. So we want here 80 micro. What's V0? 500 micro. E minus T over, and the time constant is 0.577. So let's cancel. 80 over 500 log that will give me minus T over 0.577. So if I just put minus 0.577 times log 80 over 500, I get my T. So 1060 milliseconds, roughly. Okay? How much charge is in the capacitor when it is at this level of voltage? Well, you have a couple of formulas you could use, I think. You could say Q equals CV, because we know the C and we know the V. So that would be 0.1 times 80 times 10 to the minus 6. 6? Isn't it this? Yeah. So that would be 80 times 10 to the minus 7. Yeah? Now, what would be the nicest way to write this? Micro or nano? No, I'll go back. 8 nanocoulombs. Isn't it? Sorry. Microcoulombs. Thank you. Okay. What is the voltage and the current after 1200 milliseconds? Okay, well, that's just using this formula. Voltage equals V0 E minus 1.2 over 0.577. So, yes, when you're ready, Monica, thank you. At least I have one student who's helpful.
Yeah.
6.25 times 10 to the minus 5 volts. What would be, if I, that would be 625 millivolts. Okay. And then lastly, how can I get the current? Well, if I wanted to, I could use this, but that would be foolish, because instead I can just use this, because I know the R and the V. So I equals V over R. What did we say the R was? I forget. It was earlier. 5.77. What's that? Thank you, Monica. In my head, Monica, what I did was I divided this by 100 to make it, no, that's silly, sorry. Oh wait. 10 to the minus 3. I multiplied this by 10 to the minus 2 and multiplied this by 10 to the 2. Yeah. No. Yeah, dang. I should be 10 to the minus 1 here and 10 to the 1. Oh, calm down. 62.5 and not milli, micro. Oh, give me a break, dude. G. Oh, thank you. Which answer was that? G? No, that was H. Huh? Thanks. So that should be 62.5 micro. Thank you. And then what's the current? Okay, so I need to change this then. That's 62.5 and that's 10 to the minus 6. So what do I get here? KJ, you got a calculator?
I instead got the answer.
Ah.
Probably.
Oh. What you got, Monica? Okay. This one. That's fine. So if I divide this by 10 and multiply this by 10, that'd be 10.8 micro amps.
It's okay to use the graph for different text.
No. Oh. Yeah, that's a good question actually. All I can tell you is what they do in the marking scheme in the exam, and they don't use the graph unless they tell you to. Because we needed it to get the time constant. Okay, number 2. Did I give you number 2? Yeah. So how long does it take for the voltage to half? Yeah, time constant about, yeah. So, basically I want to know when will we have a half V0. Well, that's not so bad. What can I do? I can cancel. Cancel. Log a half equals minus t over tau. That's minus 0.69 equals minus t over tau. So 0.69 of a time constant is how long until the voltage is halved. Calm yourself down there, Monica, okay? This isn't Einstein stuff here. Okay, there's a very low standard in this class that you're exceeding. I'm only joking. I'm joking, mostly. You're offended for them. Yeah. Okay. Yes, continue. The reason I had you do this question is because we'll see this number again. In fact, some of you might have recognized its value when you studied radiation, alpha, beta, gamma. Radiation. Anyways, no matter. Number 3, yeah.
Why does it become V0?
Because my question was, how long until you have half the voltage? So if you started with V0, I want to know when will the V be a half V0? What, Andrew? What, you just had a moment of understanding, was it? Okay. Continue? Yeah. Right. Number 3. How are we doing for time? Oh yeah, we'll have to wrap it up on this one. You have a capacitor with 3 microfarads capacitance, charges to 0.2 mega ohms. How long does the discharging take? Well, that's 5 time constants, but what's the time constant? Or C. Yeah, and what's the or? 0.2 times 10 to the minus 6. And what's the C? Oh, sorry, 10 to the 6. And then the other one is 3 times 10 to the minus 6. Well, that's nice because they cancel, and you're left with 3 seconds. In total, yeah. B. In total, what is the size of the total discharge? In other words, what's the Q? Do we know the Q? It's CV, right? Do we know C? Yes. Do we know V? No. Can we know V? Oh, I didn't give you enough to do this.
No.
Oh, rats. No, I don't believe that. Let me think. Lost it. Right, I'll have to add in a voltage. Monica, what's your favorite number?
7.
Okay, 7 volts. 7 volts. I didn't tell you this in the question. There's 7 volts. Okay, so the C is 3 times 10 to the minus 6 times 7. So that's 21 microcoulombs. Okay, C. What is the average discharge? Well, this is how much comes out. And how long does it take to come out? 3 seconds. So the average current would be 21 microcoulombs over 3 seconds. So that's 7 microamps. Sketch the true behavior. Now, the way we drew this, it made it look like I'm saying there's current, there's time, and then it will be a 7 microamps constant. But of course that's not what's happening. Instead, it's going to start higher than 7 and then drop below 7. Do you understand that this answer here, the current is only an average of a 7 microamps because we know it's discharging. So it will start with more than 7 and finish with less than 7. E. How long until the current actually drops below the value we said the average was? In other words, I guess it's like I'm saying, when will the discharge and the average be the same? So in other words, I'm asking you, when will you get 7 micro equals whatever I0 is, E minus T over tau. Now, do we know I0? No, but we can use this formula, VI/OR. Do we know V0? Yes. Yes? Question withdrawn? Well, that's what I'm going to do for this part. I'm going to say we don't know the I0, but we do know the V and the OR, so we can know it. No, that's the I, not the initial current. Now, it might turn out that the I0 is 7 as well. I doubt it, though. Let's see what we get. Strange. I thought it would be more than the average. Let's see. The I0 will be 7 over 0.2 times 10 to the 6th. 3.5 times to the minus 5. So in other words, that's 35 times 10 to the minus 6. Good. 35 times 10 to the minus 6, E minus T over RC. Did we work out RC earlier? Yep.
Isn't it 3.5? And 10
Three-
to the minus 4.
She just told me 10 to the minus 5, 3.5.
It's minus 4.
We can correct the mistake if there is one later. I just want to get this finished.
35 multiplied 10 to the minus 4.
10 to the minus 5 would be 35 times 10 to the minus 6. I hope. I'm willing to be wrong. That's what you got in the calculator. So that's right. And I've converted that correctly. Divide 10 times 10. I think this is okay, KJ. I think it is. Anyways, let's get this finished. What's RC? What's RC in this question? 0.6? Okay. No, don't pack up. I'm nearly finished. Cancel. Cancel. Log 7 over 35 equals minus t over 0.6. So the time will be 0.6 minus log 7 over 35. That should be something like, I don't know, 1 second. What do we get? Yes, I'm guessing 1 second. Let's see what we get.
Yeah,
0.97. Not bad. Not bad. 0.97 seconds. That is when the average and the true value are the same. Okay. Okay. Let's go. Off to maths now.
Oh no.
Oh, come on. Your maths teacher isn't that bad, is he?
Yes.
He's worse
He's the best.
at being the worst. Right.
We should fix this question.
I will fix it.
Oh, it's so hard.
I want to
I don't know. I think she had the drink and it was too healthy for her and it made her sick. She's just not used to it. Okay. Next physics class, I'll do Kirchhoff, and then I'll do, in the next physics class, I'll do Kirchhoff, work power. You know what, I think our next class is a 2-hour class. Yeah, I can maybe get the last 4 worksheets done. What day was that now?
We don't have new topics.
Correct, no new topics. We have 2 hours tomorrow. Good, so I'll finish this tomorrow morning. On Thursday, I'll take you for exam prep hour.
Okay, thank you.
And